Right. Now let's see the next one here. Lens silvered with one surface. That is silvering of lens. We used to call this one. Silvering of lens. When the generally we used to back surface of a lens is silvered. Then in the case, what happens now here? Lens. Let us consider we have taken the convex lens. And convex lens back surface is silvered. When the back surface is silvered, now let's see what will happen. Now this surface, this side, which is silvered. Silvered means what? Tell me now. It will be act like this part will act like a mirror only. It does not allow the light to pass. So if you have taken this, our regular mirrors are there now. Back side, it will be silver. They will be rough. They will do. They will go do what some coating will do. That is called as silvering. Yeah. So if we have the object is here, let us consider now. See this thing in this case, this light ray. What happens now? Light ray which will incident on this surface. Okay. And so this part which will be what terminal, this is like a this is the lens, isn't it? The lens, because of the lens, the light ray will get refracted. It is the lens will refracted like this, changes the path like this, and it will incident on this surface, and this second layer will behave like a mirror now. Then the light ray will get reflected by this side like this. Is reflected. The light ray will get reflected like this. Now again the light ray is which when it is incident at the lens surface, the light ray will get refracted now. It changes the path. The light ray will changes the path like this. Okay. Now this light ray will have two refractions and one reflections. Now this light ray has what tell me now? Two refractions and one reflections, isn't it? So here on the surface, now here is refracted, here it is reflected, here it is refracted. The light ray has two reflections, two refractions and one reflection we have, isn't it? Now, so that's why the focal length of this combination, which will be given as, and this overall, this light ray will behave like a concave mirror जैसा काम करेगा. Will behave like a concave mirror. Then the equivalent focal length of this whole combination, which will be given as, that is, the light ray will have a equivalent focal length. Yes, so 1 by F equivalent equal to the light ray experience two refractions and one reflection. So that's why reflection is because of the mirror. That is 1 by Fm. Fm means what? Tell me now. Focal length of the mirror plus, and then the light ray has the two refractions. That's why we have two times. The refraction is because of the lens, and the overall this silvered lens will behave like a concave mirror. That's why the equivalent focal length is negative. So that is minus 1 by F equivalent equal to 1 by Fm plus 2 by Fl. Okay. Hmm. This is the equivalent focal length. Done. Now, let's see the some cases now here. Look at now. When plane surface is silvered in a plano-convex lens. Plane surface is silvered in a plano-convex lens. So that means we have a plano-convex lens. And here which surface is silvered? Which surface is silvered here? Which surface silvered now? Hmm. Yes. Which surface is silvered? Plane surface is silvered. This is the plane surface now, so this is silvered. Now we need to find the focal length of this lens. We need to get now here. So this focal length, equivalent focal length of this lens. Let us say this will have a radius of curvature R1. Let us call this as a R. And this is the radius of curvature. Plane surface now radius of curvature is infinity. And this lens will have some refractive index. Let us say the refractive index is mu. Yeah, you tell me now here minus 1 by F equivalent equal to what? Tell me now. 1 by Fm plus what? Tell me now. 2 by Fl. Where Fm means what? Tell me now. Focal length of a mirror. So for let's find the first focal length of a mirror we can find. Yes, sir. Focal length of a mirror. It should be given as what we can say now here. Focal length of a mirror is how much? You tell me now. For mirror focal length, which will be given as what? Tell me now. This is R by 2. Focal length of a the R is a radius of curvature. So this means here R by 2. So this is the plane surface. Now this radius is how much? Plane surface radius is how much? How much the radius of curvature? Hmm? How much the radius of curvature for the plane surface? Radius is infinity. That means how much the focal length now? Hmm. How much the focal length now? Infinite by 2. How much? Ah, next. So the mirror focal length is infinity. Now we'll talk about the lens. We'll talk now. Hmm. Now tell me the lens now here. What is the focal length of a lens formula? That is lens maker's formula. Length of a lens, which is equal to what? Tell me. Ah, yes, that is. Mu lens by mu medium minus 1. Yeah, mu lens by mu medium. Here the medium assume it as air only. So that will be given as mu minus 1 into what you tell me now? 1 by R1 minus 1 by R2. Now you tell me now in this case 1 by FL, which will come to be a mu minus 1 into what? Tell me now 1 by R1. So how much this R1 is a plus R minus R? Y minus. So that is plus R. That means R2 value. So that is 1 by infinity. Then tell me how much will come. That is 1 by FL will come to be a what? Tell me now. Mu minus 1 by R na. This is what? Tell me now. Focal length of a lens. Now these two values will substitute in this formula to get the focal length. Equivalent focal length. That is 1 by F equivalent. Which will be equal to 1 by Fm. Fm is infinity. 1 by infinity and 1 by FL. This is directly 1 by FL or 2 we should write. 2 say we should multiply now. 2 into what tell me now here? Mu minus 1. Mu minus 1 by R. So that is minus 1 by F equivalent. Which will be equal to how much now? 2 mu minus 2 by R. So this F equivalent is how much now? That is minus R by 2 mu minus 2. This is the equivalent focal length of a. So the plane surface is silvered in a plano convex lens. Now we should this focal length with the focal length same we can use the lens formula to get the image distance. Yes. Right. And this minus sign indicate what? Tell me now. This overall, the silvered lenses always will behave like a concave lenses. Silvered lens always behave like a concave lens. Yes, this is the case one we have seen. Now let's see the next one here. When curved surface is silvered in a plano convex lens, previously what they did now here. So now here. So that means now we need to see in this case now. Now tell me now here in this case, curved surface. Yeah, any lens will behave like a concave only once it is silvered. Any type of lens will behave like a concave only once it is silvered. Now here in this case, what tell me now? Curved surface is silvered. So this is the curved surface is like this now. Now, so we should talk now here. In this case, now here this is the radius R1 and this is the radius R2. Let us say R2 equal to R we have calling. So this is a plane surface, radius is how much? Straight line means radius is infinity. And what is the equivalent focal length in this case? Silvered lens minus 1 by F equivalent equal to what tell me now? 1 by FL plus what tell me now? 2 by 1 by FM. 1 by Fm plus 2 by Fl. Now here also we need to find the mirror and the lens we need to find. Yes. Now tell me in this case, first mirror. Tell me now for the mirror. Yes. So focal length formula. Focal length of the mirror is how much you tell me now? Which will be equal to R by 2. So here the R we have now. This is the mirror, right? This is the mirror. So this radius is R, so that's my R by 2. Okay. Next. Next, we need to find what are lengths, focal length we should find now. Let's find the lengths also. Lengths also tell me. So length case, what is the formula? Tell me now. 1 by FL is equal to what? Tell me now. Minus 1 into 1 by R1 minus 1 by R2. So then how much is R1 value? Tell me. Minus how much? Yeah, so that is 1 by infinity minus R2 value. R2 value R na. What is the radius? Radius is how much? Plus or minus R. That is, we can have this as 1 by minus R. Simplify. Will come it as 1 by FL equal to what? Tell me now. Mu minus 1 into what? Tell me now. 1 by R na. This is focal length of the lens. Now we need to find the equivalent focal length. So tell me now how we'll find the equivalent focal length now. We use this formula. This is minus 1 by F equivalent equal to what? Tell me now here. 1 by Fm. Fm is how much now? R by 2. 1 by Fm means what? Tell me now. 2 by R plus what we can say now. This we should multiply the 2 say. That is 2 into mu minus 1 by R. And take LCM to simplify. How much will come? So this value which will be equal to R. Now this is 2 plus 2 mu minus 2. How much will come? 1 by F equivalent, which will be 2 will get cancelled. So that is 2 mu by R. So that is F equivalent is how much now? Minus of R by 2 mu. This is the focal length.